So this is what I was mentioning in the previous video. We're going to do all those transformations, the translations up, down, left, right, the dilations, stretches or compressions, and then the reflections over the axis. So you could see any of those when you're dealing with quadratic equations. So the horizontal translation, remember horizontal means left and right. All right, so here's what those are going to look like. Your horizontal translation, left or right, it's whatever h is. So you move h units. And remember, when you're looking at the equation, it's always the opposite of what you think it's going to be. So if it's if it's x minus something, you're actually going to the right, even though it seems like intuitively you should be going to the left. And then if it's h plus something, you're going that many units to the left, okay? So if you have x minus h, that means h units to the right, which is counterintuitive. And if you have x plus h, you are going h units to the left, which again is counterintuitive. So it would look like this. So here's your original. Okay, so you would just shift it. So you could either be h units to the right, if you had this case right here, or you could be h units to the left, if you had this case right here. So this, of course, would be a negative h. All right, so you could have either one of those. So that's what a horizontal translation looks like. A vertical translation. Vertical means up or down. And the vertical all has to do with k. Okay, so you're going k units either up or down. If you have a plus k on the end of your equation, you are going k units up. If you have a minus k on the end of your equation, you are going k units down. So this one does do what it seems like it's going to do. Okay, so let me graph this. So again, here's your original quadratic, just your run-of-the-mill x squared. We could go up k units, and your translated parabola would look like that, or you could go down k units, and your translated parabola would look like that. Okay, so that's what a vertical translation looks like. Notice it's still sitting right on the y-axis, just the same as these ones are still sitting right on the x-axis. Then, of course, you could do both. You could do both a left or right translation and an up or down translation. Okay, reflection would be over the x-axis. And this is if a is less than 0. So if you've got a negative number out front, you're reflecting over the x-axis. Okay, so your equations would look like this. Again, here's the original parabola. Your parabola looks like this if a is positive, if you've got a positive number out front. Or the reflection that you might see would look like this, and it does that if you've got a negative number out front of everything. Okay, so that's a reflection. In this chapter, we're not reflecting over the y-axis. Remember, we talked about how with parabolas, reflecting over the y-axis doesn't change anything at all. So we're not going to have a special box for that. Dilation is either a stretch or compression. Okay, it's a stretch if a is something bigger than 1. So if you stretch like times 2 times 3, and remember what this does is it ends up making it narrower. It's a vertical stretch, so when you vertically stretch, it ends up making it narrower. And then if a is a fraction, somewhere between 0 and 1, and again that's the number out front right here, it's a compression, which ends up making the parabola wider. Okay, so one last picture here. Again, starting with just your run-of-the-mill parabola. If a is less than 1, you have a vertical stretch like this. Still goes through the origin. That's very, very important. So this one would be if a is greater than 1, so it gets stretched this way. And then if a is a fraction, then it ends up wide. But again, important to note that it still goes through the origin. Okay, so this would be the example for a being some sort of fraction. 1/2, 1/3, something like that. Okay, so that's kind of a setup for all the translations that you could see. Let's do 2 examples on what those translations are going to look like. So this one, first task, if it's not in Vertex form, get it in Vertex form. So we're going to practice how to do that again. So remember, you kind of take these 2 pieces isolate them, and we'll just shove the 1 over to the side. So when we're doing completing the square, we need to factor out the -2. Leave a little space here because we're going to complete the square. And remember, we just kind of shoved that 1 over to the side because it wasn't the right number. It didn't make it a perfect square. So in here, I start with my -2. I cut it in half. That gives me -1. And then I take that -1 and square it. So 1 is the magic number here. Remember though, if I have something on the outside, this isn't really a 1. It's a 1 inside the parentheses. But if I were to redistribute, I would have -2x plus 4x minus 2. So my new addition to the right-hand side was really a -2. And I balance a -2 with a +2. Okay, so my equation is y equals, I've got a -2. This is x minus 1 quantity squared, and then plus 3. Okay, so I'm going to make a list of everything that happens. This negative flips it. Okay, so I will be reflecting over the x-axis. This 2 is a stretch. So we got a stretch times a factor of 2, so that'll make it narrower. And then my vertex, I move 1 unit right, so the x-coordinate is 1, and I move 3 units up, so the y-coordinate is 3. So those are all the important features. Let's start with the vertex, so go 1 up to 3, so that's my vertex. It is flipped upside down, and it is stretched by a factor of 2. So it's an upside down parabola that's going to be narrower than the original parabola. So it looks something like that. Okay, this one actually seems like it's not in vertex form, but really it is. And you can go off of just the original form here. So this really is in our standard vertex form. So the 2 means that it's stretching by a factor of 2. There's no negative, so it is not upside down. There's nothing in there with the x, the way there is right here. The way I know that this is already in vertex form is because there's no bx term to play around with. Okay, so let's make ourselves a little note. If there is no bx, your graph is already in vertex form. So that's just a fun little note. So keep that with you while you're working on the homework. If there's no bx, then you wouldn't be able to do this step, which means it's already in vertex form. And then the vertex, there is nothing in there with the x squared, which means it doesn't move left or right. So the vertex must still be at an x value of 0, and the +7 means it moves up 7 units. So let's do a sketch of this. So 1, 2, 3, 4, 5, 6, 7 is my vertex. It is right side up still, and it is stretched by a factor of 2. So it'll look something like that.